Hi everyone, welcome to our part 1 lesson on exponent laws. We're going to be looking at 5 different laws that deal with exponents, and the first lesson today, part 1, deals with 2 basic laws. So law number 1 and law number 2. So if you're following this video today, you should have your notes open to exponent laws, and let's go ahead and get started. Exponent laws are just shortcuts, really, that allow us to deal with exponents. So if we're asked to multiply or divide powers, and remember we talked about what is a power, that's just some value. So for example, 2 to the power of 4. So some base, okay, with some exponent. Okay, and exponent laws allow us to quickly figure out what the answer would be if we are, for example, multiplying 2 to the exponent 4, times 2 to the exponent -6 or something like this. Okay, or we might be dividing one power by another power. And they're shortcuts, but they save us a lot of time. There's 6 exponent laws that you need to know. One of them you've already learned, which is that any base raised to the exponent 0 is equal to 1. Okay, that's one of the 6 exponent laws. So 0 exponents. And the other 5 we're going to talk about now in this lesson and the next lesson. So let's have a look at the first exponent law. And exponent law number 1 looks at how we deal with a question where we have the same base, different exponents, okay, or maybe the same exponents, but the same base, okay, multiplied by each other. So multiplying powers that have the same base. So here the base is a, and a, okay, is the same value in both factors. So a to the m, okay. So for example, it could look like something like this: 5 to the exponent 2 times by 5 to the exponent 1. How do I go ahead and figure out what that answer is? And the shortcut way to do that is when we multiply powers with the same base, we add the exponents. So a to the m times a to the n is equal to a to the m plus n. And of course, you're going to have numbers for m and n, and you add them together. Let's just talk quickly about why we can use this shortcut. So where does it come from? Okay. So let's have a look at this. 5 squared times 5 to the exponent 1. Well, if I use exponent law, it tells me that the base is 5. So I can add these exponents, 2 plus 1, okay, which is equal to base 5 exponent 3. 2 plus 1 is 3. That's coming from the fact that I know that 5 squared is the same as 5 times 5. Okay, I know that's true. And then times by 5 to the exponent 1. Well, 5 exponent 1 is just 5, okay, used once. Okay, so we have 5 squared, which is 5 times 5, times 5, which is equal to 5 times 5 times 5, which is 5 cubed, okay, or 5 multiplied by itself 3 times, which we show exponent 3 to represent the cubing. Okay, so both of these values will come out to be 125 if I put them into my calculator. Okay, and for today, we're just going to go ahead and we can leave it as a power. Okay, we're just looking at how to figure out what the new exponent is in our answer. So that's where this is coming from. Clearly, it doesn't make sense for us to write out every calculation like this. That doesn't make a lot of sense. That's time consuming. So that's where we can use our exponent law to save us some time. Okay, it's a shortcut method. So let's go ahead and try some questions. Again, the first thing I always want to check when I'm looking at a multiplication of 2 factors is if I have some powers there, before I go ahead and add the exponents, I do want to make sure that the base is the same. Okay, and if the base is the same, then I can add the exponents together. So let's go ahead and do the first one here. So we've got 0.6, okay, to the power of 8, and times 0.6 to the power of 3. One thing I want to mention here is that there's a few different ways to show multiplication. When you have brackets directly beside each other like this, that means multiply. Okay, that's another way for us to show multiplication. We often in math stop using this little times sign because it can be confused with x. And so we often will show multiplication as brackets, okay, attached to each other. What we don't have in there is a plus or minus sign. So I know that I'm multiplying, okay? So let's go ahead and look at this question. I see that 0.6, this power here, okay, and this power here have the same base. The base is 0.6. So I can add the exponents. I'm going to add 8 plus 3 together. So the answer is going to be 0.6, okay, and I'm going to add 8 plus 3, and so my answer is going to be 0.6 to the exponent 11. And there's my final answer. For now, we're just going to leave it as a power. Okay, let's do the next one. Again, here's a little bit more complicated example. 2x, all in brackets. So this is my base. 2x is the base. Okay, to the exponent 4 times 2x exponent 2. Well, again, they have the same base. The base is 2x. So I can write my base, 2x. And I'm going to add those exponents together. So 4 plus 2 is going to give me 2x. I keep it in brackets to the exponent 6. I keep it in brackets because I want 2x to be my base. Okay, I'm going to leave my answer like this for now. But later on, we're going to apply that exponent 6 to both the 2 and the x in order to get rid of the brackets. But for now, we can just leave it exactly like this. I'm just looking at adding my exponents together. Okay. Let's do another one here. Again, here I have 9 to the exponent 5 times 9 to the exponent 2. Again, the base is the same. The base is 9. So I can add those exponents together. It's true that one of them is a negative exponent, but we can still go ahead and add them together. If at the end we still have a negative exponent, then we could deal with it. We could flip it and make it positive. So we have 9 as our base, 5 plus negative 2. So you add them exactly how you see them. Okay, if one of them is negative, it stays negative while we're doing the addition. So 5 plus negative 2 is equal to 3. Okay, 5 plus negative 2 can also be written as 5 minus 2, and that's equal to 3. Okay, so there's my final answer. And I'm going to leave it like this for now. Okay, I could figure out what 9 times 9 times 9 is, but we're just going to leave it as a power. Okay, great. Let's look at dividing powers, okay, with the same base. So this is the opposite situation. Instead of multiplying two powers with the same base, now we're seeing them written as division or as a fraction here. Now, remember that when you see a number in a numerator and there's a number underneath it in a fraction, okay, that little line that separates them out means divide. Okay, so this is the same as a to the m divided by a to the n. Okay, and we often use a fraction or a ratio rather than this format. Okay, in math, we usually show if I want to divide something, some number by another number, I will often write it as a ratio, and the number on the top gets divided by the number on the bottom. When I see a question like this, and if I have powers with the same base, I can subtract the exponents. Okay, and you might say to yourself, well, where does that rule come from? Let's do an example. Okay, let's go ahead and look at this one here. 7 to the exponent 5 divided by 7 to the exponent 2. Well, I could also write 7 to the exponent 5 as 7, okay, multiplied by itself 5 times. So there's 7 times 7 times 7 times 7 times 7. There's 7 exponent 5. And on the bottom I have 7 squared. Well, that's just 7 times 7. Okay, so that's another way to write 7 to the exponent 5 divided by 7 squared. And what I would notice is that every one of these 7s on the top, okay, 1 7 here will cancel with 1 7 below it, which gives me 1. 7 divided by 7 gives me 1. Okay, there's 2 7s on the bottom, so I cancel 2 7s on the top. In other words, I get 7 times 7 times 7 over 1. Okay, so each one of these, 7 divided by 7, just gives me 1. And so my answer, simplified, if I wrote that as a power again, I would have 7 times 7 times 7, which is 7 cubed. Okay, so again, this is not an effective way to solve every type of question, because the larger the exponent, the longer a question like that would take to solve. So instead, what we do is we say, well, if every one, if every one of these 7s cancels with 1 below it, then I simply just look at how many I have on the bottom, and I can cancel that many with the top. In other words, I can subtract the top exponent. I can subtract the bottom number from the top number, and that will give you my answer. So I could also use my exponent law and say 7, 5, subtract 2 will tell me what my exponent is in my answer. So 5 minus 2 is 7 cubed. Okay, great. So let's go ahead and do some of these. We don't always deal with numbers. Sometimes we deal with variables like x and y. And so here's a good one. We have x to the power of 6 divided by x to the power of 3. And again, every one of these x's down here that I have will cancel with 1 on the top. So what we get is this is equal to x 6 minus 3, which is x cubed. 6 minus 3 is 3. Okay, and there's my answer. So they save us a little bit of time. Okay, I think you've got one more in your notes, and it is this one here, a little bit more complicated. I have 2x cubed divided by 2x to the negative 2. This is a division question, but what I notice is that they have the same, both these powers have the same base, and the base is 2x, okay, because that's what's in brackets here. So what I'm going to do is say that's going to be 2x, and I'm going to subtract the bottom number from the top number. So we get 3 subtract negative 2. There's a negative 2 on the bottom. I'm going to subtract that negative 2. Okay, so I get 2x, there's my base, and my exponent is now going to be, well, 3 subtract negative 2. This is just dealing with integers here. These are our integer rules, and subtracting a negative number is the same as adding that number. Okay, when I subtract a negative, I undo the negative, and so I actually have 3 plus 2. Okay, so I get 2x exponent 5, and that's my answer. And I'm going to leave it like this for now. Okay, so on your questions, your worksheet, you can also just leave it like that. Okay, for now. All right, so again, another way to solve this question, if we look at it, if you see that negative 2, just to show you how the exponent laws all come together. Okay, another way that I could have solved this is that whenever you have a negative exponent, you can write that negative exponent, or write that power as a power with a positive exponent if I flip it, or I bring it up to the top and I make it positive. So if I were to flip or bring the bottom base up to the top, I would get, well, 2x cubed stays on top, but I would be bringing up 2x squared, and that negative 2 would become positive when I brought it up, when I flipped it up. And so here we're back to exponent law number 1, where I'm multiplying two powers with the same base. And so we get 3 plus 2, and my answer will be the same, 2x exponent 5. So again, there's more than one way to solve these problems, but this is a fast and easy way as well, because we have two powers being divided and the base is the same. So we simply subtract the bottom number from the top number. Okay, then we'll get the correct answer. I'd like you to try at this point your worksheet. So it's exponent law worksheet number 1. Okay, so sorry, it's not part 1. Okay, it's exponent law worksheet 1 in your worksheet package for chapter 4 and 5. And I'd like you to check your answers for these, please. So do your best. There's lots of practice questions. You can leave your answers in exponent form as a power. That's fine. You don't have to, for example, for an answer like this, you don't have to go any further than that, but just check your answers and make sure you're doing that correctly. Okay, there's a few challenging questions on there at the bottom. They have a happy face next to them, so you know they're challenge questions, and I encourage you to try those as well. Okay, so good luck. Thanks for joining me. Bye for now.